Hello all and welcome back. So in this video, let us continue our discussion on linked list. And now let's try to delete the tail node in our linked list. So let's get started. Now I have drawn a linked list which is in front of you. Again, we have seen this many times. In this linked list, this is my head and 40 is my tail, right? So 40 is the tail and 10 is the head. Now our whole aim is to delete 40. Okay. And one more thing, everyone. So all these operations we are doing because these are the very basic operation which we can do in a linked list, right? Along with that, as I've told multiple times, going forward, the understanding which we developed by doing all these operation, that is what going to help us in solving those questions, right? If you are able to just do all these questions, believe me, all these operations, 80% of questions you will be easily able to do. Okay, great. So now if we see, if I have to delete this particular node, okay, then let us think how exactly can we go about it. Now, what I feel is that if we want to delete this node, the node 40, just like we did in insert, we should have some pointer through which we are able to reach at this position. So our temporary pointer, which we are going to make, it should be able to reach this position. The reason for that is that if I reach on tail node, then how will I delete the same from my linked list? I will repeat it again. When you have to insert something at tail, okay, insert something at tail, we need to change the connection, this connection, right? But when you have to delete something, okay, and this is going to help you a lot in future as well, the understanding of this thing. If you want to delete something, then we have to change the connection which is before that node. So I think this is a very important learning. So we'll write that as well. When we want to delete a node, we stop at a node before, right? Similarly, when we have to insert a node, we stop on the node where we will insert. Okay, so again, everyone, this is very important points. I will again help you to understand this. When I have to delete a node, so if this is the node I have to delete, I have to make sure that I stop here because this is the connection which joins this particular node to my linked list. On the other hand, if I have to insert a node, let's say at tail or at this position, then I have to make sure that I stop here. Or if I have to do at tail, then I have to make sure that I stop here. Okay, let us discuss for tail only for the time being. When I have to insert for tail, I have to make sure that I stop on tail node. But on the other hand, for deleting, I have to make sure that I stop at node which is one before the tail. Okay. So I hope this is clear, everyone. Again, going to help you a lot. So now let us understand what is the overall property which this node has. Okay. Now, as like ever, linked list node has two properties, data and the next. Data can be anything. Of course, we don't have to worry on that. The next property I think which we can use is while temp dot next, right? Dot next is not null. So this I think is the condition we can use because if I have to stop at this node, then I have to add some condition. The condition should be that my next node is a tail node, right? To check if my next node is a tail node, what we have to do? We have to just check the next of next, right? So yeah, this is something which we are gonna write our logic on, everyone. So pay attention. So let us just write a function here. Def delete at tail head. Now, as always, let us first handle the base case. Okay, so what is going to be the base case? The first one I think is if our head is none. Pretty straightforward. If our head is none. What was the other base case which I always ask you to handle is when we have a single element. Now, when we have a single element, in that case also we will delete that node, right? In case when I have just a single element, I will delete the node. When I have a single element, what does that mean? That effectively means that or head dot next is null, right? So this is what a single element tells me, right? So for example, if this is a linked list, then this will be none. Now because this is none and let's say this is my head and this is only my tail, I want to delete the tail, right? So you will be deleting the head as well. The check is if my head dot next is none, right? So yeah, I think that can be used. We can just return none because it is my linked list which is empty. If the list is empty or has one node, right? Great. So in a way, you will see that to check the tail node, this is actually the check. Head dot next is none. Okay, so I can actually create another function def is tail node. In that, I can get a node. I can maybe let's say get a node. And how can I check if it's a tail node? If my node is let's node dot next, if it's none, then I can just simply return true, right? I can say that. So again, this can be another function which you can ask to write. And if node is none, then I can simply say that in a similar manner, we can just return true here as well, because again, it's a none node. In all the other cases, I can return false, right? So this I'm just telling you that to check. Again, if we go back to the diagram and see, a tail node is the one whose next is none. We have seen this multiple times, right? Great. So now let us write the code for this. We have handled the cases, the edge cases. Now I have to just make a temp which is head. Okay. Now till when I have to run? While temp dot next dot next. Okay, so either you can do it like this, or we can now use this function as well, is tail node. Okay, so maybe I can pass temp dot next here. So all I'm doing is I am asking that, hey, stop me a step before when there is a tail node next to me. So that is what I'm doing. Temp dot next. This is a tail node. Okay, stop me. So this is something which we are doing. So while temp dot next is not none, we just have to keep on increasing our temp. Great. Now once I've done this, I will be coming to this particular node. And if we are on this node, to just delete this last node, I just have to change the next pointer and make it none, right? So this is the property which we have to use. So now just this will become none. And let's delete this connection, right everyone? So pretty straightforward. Just we have to understand that what exactly in deletion we have to do. So temp dot next equals none, and we can just return our head. Pretty straightforward, I believe. We have just understood how to handle the deletion case. That is to stop a step before. Great. I think, yeah, this will work fine. Let me run this quickly. Here. So 10, 20, 30, 40 minus 1 seems to work fine. 10, my bad. Minus 1 seems to work fine. So for an empty linked list as well, it's working fine. 10 minus 1. For a single node as well, it is working fine. Okay, everyone. So I hope the overall understanding is clear. Major case is just that only. So if it is 10, 20, 30, 40 and minus 1, I am stopping at 30 here because of this this whole code. Okay, I can just do one thing as well to show you print temp.data. Okay, data of node we have stopped. Great. So let us run this. So it's a lot more clear. 10, 20, 30, 40 minus 1. See, data of node we have stopped is 30. 10, 20, 30, 40. And we have finally just deleted our node. Right, everyone? So please make sure that again, I'm helping you to visualize all these stuff so that you remember and understand. If you require, you can just run this on Python tutor as well. Though I think it should be a lot clear with this diagram as well. Okay. Will suggest that always practice with diagram as well. In interviews or any OA, we might not have Python tutor, right? So understand, but then try to draw the diagram for that as well. So that's why I'm using both the overall techniques so that you understand and remember everything. Okay, cool then everyone. Now in the next assignment which you will get after this, you have to try and do this question recursively. So we have done the same thing by iteration. You have to now try and approach the same question by doing by using recursion. So yeah, please try to just do it once. If you get stuck, there will be hints and a solution video which you can refer to. Thank you.